Hello, Jonas Ekman here from Team Sweden in F3B. I want to walk you through how to set up an F3X model using the Futaba T18MZ transmitter. We're going to utilize all the 8 flight phases. I'm going to give you some tips on some extras. But mainly this tutorial is the basics how to set up a modern F3X glider. So some of the functions I will go through and then clearly tell you that you need to repeat it on each and every flight phase and so on. And some functions I will do to the end for your understanding and to get a better flow during this tutorial. I really hope that you like it, and please use it as much as you can for programming your glider. First, we are going to create a new glider, and for doing that we can go into the model select, and here we have the location where to save all the gliders when we do that. Currently the one I'm in is saved in the transmitter mode. You also have an SD card in this radio. But first we'll set up a new glider. So new. Then we want to have the model type. Here we can choose airplane, helicopter, glider, and electric glider. And we are setting up a glider. And we are going to use 2 aileron, 2 flap. And we are going to use a V-tail configuration at the end. So we have a new model, and it shoots us directly into what system type we are going to use, which 2.4 GHz system, and we are going to use the fast test with a telemetry function. We are only going to use a single receiver, not a dual receiver. I'm not linking any receiver right now. That's for a later stage. So going back here, we now have entered a new model into the model select box, and we'll rename it. We'll rename it F3X, for example. Okay. The next thing that we are going to do is that we're going to pull up all the endpoints on all servos. So we get 155 on limit, and that we get a 140 on travel. The reason for me doing this is that we are just after this going to calibrate the throws, so it doesn't go into any mechanical stop of the glider. If you have a servo that continuously go into mechanical stop, you will sooner or later burn the servo and get a poor function. And last we'll pull up the butterfly also. And as you can see, I'm using a mouse connected via the USB port, which increases the speed of programming drastically using the 18MZ transmitter. So all the limit and travels are at the maximum. So we can go back. And what we are going to do, the next step now is that we are going to select what kind of conditions are we going to use, or we call it flight phases or whatever. Conditions, flight phases, or what you're used to. To be able to set up that, we'll go into the model menu. Sorry. Here. Under the condition select, we can add and deduct and rename and prioritize conditions. I'll add all of them right now. I'm going to use 8, so I add 8. Okay, so now I have 8 conditions in the program, and the next thing is that we are going to assign them to switches, so we know where they are going to be when we turn a switch and so on. So we'll start with this condition that is on top, which is number 1. Number 1 is also the figure for the lowest priority condition. I'll come back to that later when we rearrange the conditions. These conditions I'm going to rename and put it as a distance, which is the condition that are closest to the setup of the wing, where you have no preset of the flap or ailerons or anything like that. So you have as close to standard wing as you can. So distance. This one, the next condition, let's call it speed condition. Speed condition I'm going to use on a switch, single or logic. Here you can choose if you want to have a logic setup where you can use 2 switches or sliders to get the activation of a condition, if just you want a switch. And I'm using single right now for a switch, and I wanted to have it on SE. So I want to have speed mode on SE, and I want it on the on position there, like that. Close, close. So now I have speed set on SC. If I go out, you get distance again. The next condition I want to have is, let's say, thermal. Sorry about that. So we got thermal. I wanted to have it on the same 3-position switch. I have set up, the beauty of the 18MZ Futaba radio is that you can assign any switch anywhere. So I have a 3-position switch here, and I have a 3-position switch here. So I'll continue using the SE. And for thermal, I'll have it here, as it says, on there. Good. So now I thermal, distance, speed. 3 conditions already done. The next one is I want to have launch, for example. So launch, I'll have a single and I'll use the SF switch, which is also a 3-position switch, so as you can see here. And I'll start having launch on that one. Good. Then I want to have a second launch phase. Launch 2. And for that one I'm going to use the same SF switch, but in that configuration. Good. So launch 2 and out, and then it goes back to whatever I have the other condition set. So I'll go out in speed, for example, during the launch phase of the winch. The 6th condition, I would suggest that we set up a landing condition. Having a separate landing condition enables you to have separate aileron differential or separate throws or whatever. This also gives you the possibility to very accurate program smooth landing, so you can score the 100 points in the landing area for the points for the landing. So let's call this one landing. Great. And how I want to have the landing triggered or activated, I'm going to use the J3 stick, which is my normal stick, the normal stick for butterfly. And I want it to be activated a few steps down here. So I enter, and get red is off. Yellow is hysteresis, which means it's on, but it doesn't give you anything, and green is on. Having a little bit slop in the top here gives you the possibility that if you accidentally, during a rudder input, come down here, it doesn't affect the condition. But if I start to pull, you see here it shows landing. If I go back, is speed. Okay, so that was a landing condition. The 2 last ones in this example I'm going to use as, for example, a second distance mode or distance phase. Let's call it distance fast, for example, if you want it to be a distance setting where you might fly a little bit faster than normal. Distance, let's call it fast. Distance fast I want to be able to enable if I am in distance mode, which this shows here. And then I want to pull another switch. So that's why when we're going to use the logic function, and we are going to use the and function. You can have and, or, XOR, or close. So the manual clearly shows you in a good matrix what each and every of these logic setups are doing. If you have an AND function, it means that both switches or sliders, whatever I assign here, has to be at an on position to be valid. So I'm going to use a single switch, which was the SE, where I had my distance, which is in the middle. That's an on. And then I'll go on to a SG. And when I hit the SG there, I'll get the distance too. So I have on a separate, I can go between distance and distance fast. The last one, I'll do the same, but I'll be using a second thermal condition. It can be very useful if you want to trim the exact minimum sink setting, for example. I mean, looking into the polars of a good glider, you really need to come down in speed and so on, and have the full amount of flaps down, and it's an easy way to set up a minimum sink. Here I'll also do logic. I'll do the same. I'll start with the SE, and the SE was on thermal, which is here. Sorry, it's there. Close, and it's going to be on an SG, that one. Close. So if I pull thermal 2, distance and distance fast. There are so many ways of programming conditions, so it's a personal choice. This is a good basic setup. Okay, going back to the throws. We are going into linkage menu. Just ensuring that we have the throws on aileron, etc. The AFR section here is a very important one, because here you set the performance or the how you want the servo to react. You can use exponential. I'm a thumb flyer, so I definitely know that I'm going to use a expo on an aileron, for example, and not a reverse section. I'm going to use an expo, something like that. That's 50% is a lot, but just for giving you an idea to visualize it a little bit better. I have not yet changed this box, which stands for group or single. The difference is that if you do any programming here and have it on a group, it will immediately be valid for all the flight conditions. And at the end of the day, we are not going to have the same exponential curves or throws or whatever in a speed flight condition compared to a thermal flight condition. So after you have programmed it exponential here, I would suggest that you go use this as a single. And now it's very important that you remember to take all the flight phases. Oh, sorry. don't know which priority I have for launch 1. I'll sort that out later. So put single on the aileron and use the same setup on all conditions for aileron, for elevator, for example. So you see, you need to each and every servo on each and every flight conditions. I'm not going to do all servos and all functions, and I'm not going to do all flight conditions, but you get the point. You also need to assign if I'm going to have exponential on the elevator in the distance which I'm going, and maybe I'll have some exponentials in the speed, and I know that will be the case. So think twice while programming this, so you don't mix up forgetting the single or group. So you overwrite something, because if I'm now going into a group here and I change a value like that, everyone that has a group is going to get that value. I don't find another one. Okay, lucky you that you didn't see that example. But my main point is, think twice, take it easy, ensure that you have your single or group correct. Choose the type of curve for the throw. Now we are going to look into how are we securing that we are not going to break the servos. I said earlier that make sure to use the endpoints. We have pulled these up to maximum. Now you go into the endpoint on an aileron, for example, and then you find out where is the maximum throw in a symmetric mode, meaning the same throw up and same throw down. What is the max? And that might be, let's say it's 130. On that one, it's as an example, that's 25 millimeters up. So 25 millimeters down is the same as 127, for example. Setting the endpoint so you get a symmetrical travel enables you to use the servo throws the best. It gives you the possibility to increase and decrease when you have set the actual throws, which 99% is lower than the maximum possible endpoint throw. I hope you got that. It's a little bit complicated perhaps to explain, but the meaning now is to avoid mechanical stop during the throw, and you let the lowest rate when it hits the mechanical stop to be the one that shows us the next one, so to say. So I got, as my example, 25 millimeters up and 25 millimeters down. And then I do 25 up and 25 down on the aileron. Then I've set the endpoints. And then you do the same with flap. The flap you can leave right now. Sorry. I'll come back to that. It's very important that you leave the flap right now to maximum. But you do this for aileron, rudder, and elevator. Aileron, rudder, elevator. Then it's of course needed that you'll might need to do some servo reverse if the servo goes the wrong way or something like that. You hit the servo reverse function here. Very straightforward. By this time you might have found out that some servos is not moving. For example, the flaps might not be moving when you pull the aileron. And that's because if we go into, if we go into the linkage menu, we go into the function. The function menu dedicates a function to a control. And I'm a mode 2 person, so I have aileron on joystick 1 and I have elevator on joystick 2. Joystick 2, you see here, elevator. Aileron was joystick 1. However, I have not yet assigned the aileron 2. The aileron 2 on channel 5, I have not assigned, so I'll need to do that on J1. I want to have the T1 trim mix, or T1 the trim, flaps, on J1. And then flap 2, same there. So this function now I have assigned aileron, elevator, rudder, aileron 2, flap 2 to a control. Default, it was also assigned butterfly to joystick 3. If you want, you can put a trim on that one. Here you easily can state if you want the trim T1 to be as a combined trim, meaning covering all flight phases wherever you are, or if you want to have it as a single. If you want to have it as a separate with single, non-global, non-group. But I want to keep them as combined right now. Now we have set up all the functions, we have set up all the conditions, and we have set up symmetrical throws on all rudders. So now it's time, or actually we could what I'm going to cover right now is how to set up the trailing edge of the wing. You could use to do this before you set up the symmetrical throw. Sorry for that, but here it goes. To set up the trailing edge, it's really straightforward. You go into the linkage menu, nothing else, and you hit the subtrim. The subtrim is going to offer you to individually on each servo trim the middle point. So for aileron, we can hit and put in the subtrim, so you get a nice trailing edge according to the airfoil. The elevator needs a little bit adjustments, and the rudder. On the V-tail configuration in this menu, it is called elevator and rudder, even though it's a V-tail. I'll later show you the mix where you set up the throws. So come back to that. This is just for setting the airfoil accuracy. And the rudder, let's say as an example, we need to hit a little bit down. We are going to leave the flap and flap 2 just now. I'll come back to them shortly. So now we have a nice airfoil over the aileron on the left side of the wing. On the right side of the wing we have a nice V-tail setup where you have zeroed out the elevator and rudder. Now, for a modern version, for a modern F3X ship, to get the biggest throw possible for flap in butterfly function, you need to use some sort of preset servo. Meaning that when a servo is at its zero, you have some deployment of the flaps. And this is, of course, you get the maximum throw for a good function of the brakes. So what you do to get the best possible throw is that you are going to sub-trim the flap when you have the joystick J3 50% down. Joystick J3 50% down. In that, then you have both flap servos partially deployed. In that area you sub-trim them so they align as close to each other as they can. And it's really beneficial if you have these two numbers as close as possible. So now we are joystick J3 50% down in butterfly mode. Then we pull the joystick up to the top, and the flaps are still slightly deployed due to that we have set the servos in a preset manner. And sorry about that. And in this area we hit the flap settings menu. Here we can line up the trailing edge with the offset. Usually it's 50 to 80% or something like that. So now this function is lining up the flap according to the proper trailing edge with the alignment from the aileron. So I'll repeat: sub-trim the flap when you have the stick 50% deployed, so you get this a linear flaps down, and then you hit the flap, the joystick J3 up, and you go to flap settings and you work them up to the linear trailing edge. And the last step to get the good butterfly is that you pull the joystick maximum down